Hi, this is Calandra. In this video, we're going to talk about the meaning of relations and functions. A relation is a rule that relates an input and an output. Often relations are written as sets of ordered pairs. A function is a special kind of relation in which every input has exactly one output. The input is typically represented by the variable x, and the output is represented by the variable y. Determining functions from sets of numbers. Determine if the following relations are functions. So starting with part A, we have a set of ordered pairs, which is a relation. So to determine if it's a function, we need to figure out if every input, which are the x values, have exactly one output. So every x would have to have exactly one y. So to do this, we might want to draw a little illustration. So I'm going to make a little table, and I'm going to map my x's to their corresponding y values. So remember that ordered pairs are always in the form x comma y, unless you're told differently. So my first ordered pair, I see when my x is 2, its output is 0. So far so good. My input has exactly one output. My next point, when my input is 4, its output is also 0. Well, this is still okay because that input of 4 is getting mapped to only one y value, which is 0. Then lastly, for an input of 6, its corresponding output is 1. So this is a function. Looking at part B, we can do a similar mapping. Starting with our first point, when x is 5, its corresponding y value is 4. When x is 3, its corresponding y value is 2. When x is 5, and notice we already have 5 represented in our table, we have an output of 1. So that 5 actually gets mapped to two different values. So we can stop there and say that this is not a function. And that's because 5 has two different y values. Or we can just say 5 has more than one y value. And that contradicts the definition of a function. Determining functions from equations. To do this, you should solve your equation for y. If you come up with y is equal to any quantity, where you have y isolated on one side of the equation, then that equation will represent a function. If you have that y is equal to plus or minus some quantity, once you have y isolated, then it is not a function. So let's look at a basic example of this so that you can see why. So let's say that my equation is y is equal to plus or minus x. Then if we created a table, let's say that I put in an x value of 3. Well, if I substitute 3 in for x, that means my y is equal to plus 3 as well as minus 3. And that means that we have an x with two different y values, and that would not be a function. So that's what you want to be cautious of when examining equations. So determine which equations below represent functions. In the first one, I see that y is already by itself. There's no plus or minus, so I know that this one is a function. So I'm just going to put yes. In my second equation, before I can answer, we need to solve for y. So I'm going to subtract 2x to the other side. So we'll have negative 4y is equal to a negative 2x plus 10. And now I'm going to divide both sides by -4. To simplify this, although we can get our answer just from looking at it at this point, I'm going to simplify it a bit nicer. I'm going to factor a -2 out of the numerator. Since I'm factoring out a negative, that's going to change the signs of everything in my parentheses. And by doing that, I can now cancel out the -2 with the -4, leaving me with 2 in the denominator. So this equation simplified to be y equals x minus 5 over 2. We don't have a plus or minus, so I know that this is a function. Okay, looking at part C. We need to isolate y by itself. So if you remember a few lessons ago, we learned about the square root property. So when we apply that, that means that y is going to equal plus or minus the square root of x. Well, we have that plus or minus, which tells us that it's not a function. And I give you a hint that any equation will not represent a function if y is raised to an even exponent. Because when you solve it for y, you'll always end up with a plus or minus case.